Hi everyone, welcome to our new webinar, which is called Serverless AI. Today joining us is another really special guest who is a regional director at Microsoft. So let's welcome Daron Yondem.
Hello. Yeah,
Hi,
I'm on
how are
stage.
you?
Good, thank you. How about you?
I'm good. So can you give us a little background of what you do and what you'll be talking about today?
Oh, yeah, I do a lot of things. I mean, the Microsoft Regional Director Program is just one of the things I'm in. And
Mhm.
just to clarify, I know this is going to sound confusing, but Microsoft Regional Directors, they don't actually get paid by Microsoft, which is a nice thing if you want to stay independent. I know that sounds weird, but if you want to do some research, go ahead, do it. I'm not going to go into that right now, but I'm in the Microsoft Regional Director Program, Microsoft MVP program. My day job is I work in a OTT platform that is focusing in Middle East and Africa. It's called Blue TV. We do streaming and a bunch of other stuff there. And in this session, I will talk to you about, the serverless AI. That's the topic of the day.
So anyways, it's great to have you here and I wish you the best of luck for your talk. So now the stage is yours.
Thank you. Thank you. Let me share my desktop and start from there. There we go. Okay. Okay. This is what it is. So let's start. So, yeah, I mean, let's start with my first slide, to be honest. This is pretty much everyone for the recent, 6 months, 1 year, or a couple of years, wherever you got into this, everyone is about machine learning. Everyone is about AI, right? If you look at your LinkedIn feed or even Twitter feed, obviously Twitter based on who you are following. But long story short, I mean, people are crazy about machine learning and AI. And, if you're in the industry, then it's like, it looks like that is something that you got to jump into. And if you're a student, it looks like that is something you got to learn to be able to find a job, right? I mean, it's the trend nowadays. And that's what it is. I mean, we're gonna need to look at this from a different perspective because, it doesn't matter if you're a student or someone who was working in this industry for like more than 20 years. It doesn't matter. The topic is, should we just jump into this without asking the questions that I have put in this slide deck? So what are these questions? When I started getting prepped to this presentation, I was like, what would have the best output in an hour, in 50 minutes, or whatever long the session will take. But the point is, we all want to learn AI. We all want to learn an expert about AI. But what do we really mean about it? What does it mean to learn AI? Because if you're putting a goal, that needs to be quantifiable, right? If it's not quantifiable, then it's going to be an endless journey where you're not going to really you will not even know when you got where you want to be, right? So what does it mean to learn AI? That's an important question to ask ourselves, because you might have seen other presentations out there. Most of the AI presentations or machine learning presentations, they start with this huge tree of topics that starts AI. It goes down, it goes general intelligence, and it goes as down as deep learning and all these facets of AI. And I am guessing, there might be exceptions, but there's no way you're going to be able to learn all of the, knowledge out there about AI. So you got to pick something, right, at the end of the day. And when you're going to pick something out of that huge domain of knowledge that exists out there, you got to think about your purpose. What is our purpose in learning AI? Why do we want to learn AI? Because at the end of the day, we need to keep in mind that there's this joke that about art, right? Do you just paint for the sake of painting, or do you just paint for the people who are going to look at the painting? So my point is, are we just working on technology just for the sake of the technology, or are we just working on technology just to serve a cause? And when you look at from AI's perspective, if you start thinking about the purpose, that kind of starts helping you figure out what path you really want to go, instead of going out there finding all these trainings on LinkedIn or in other places and trying to learn as much as possible and hope that at one point you're going to feel that you know AI, which again goes back to our first question: what does it really mean? Another question is, what drives you learning AI? This goes along the purpose question, right? What is the primary driver? What is the problem that you want to solve that is pushing you to learn AI? Because to be honest, at the end of the day, if you don't have a purpose, you don't have really a goal, why would you learn AI? And I can't imagine some of you, asking right now, like, I just want to find a job. Obviously, that's a whole different topic. There's a bunch of different variables there, but yeah, that's going to be a long topic to discuss. So let's not get into there. But again, you need to think about, does learning AI, and what does that mean, by the way? Does learning that will, get you a job? Then, in order to answer that question in a succinct way, maybe you should go and do a market research. In this case, market is the job market, and figure out where is a lot of demand, and then learn, what you have to learn, because at the end of the day, there's no way you're gonna, get the whole domain covered. And the final question is there something else? I mean, this is especially important for students because, they have a lot of area to cover because they're at the beginning of their journey, right? And we should think about this from a perspective that we are investing time into learning something, and what is the return on investment? Sometimes I do this joke, like, you might buy a MacBook, right? That's fine. But if you're buying a MacBook because it looks sexy in a third wave coffee shop, then you might not be doing the best investment there, right? It depends, but I'm just questioning, right? So you got to think about, what I'm investing in this and what I'm going to get out of this. And based on that, is this the best, path moving forward? So to simplify that question, is there something else that I should learn that will get me more return on my investment of time than AI? And am I being sucked into this trend just because I'm seeing a lot of AI stuff on my LinkedIn feed? And keep in mind that whatever you are seeing on your LinkedIn feed or Twitter feed, it's just perceptional. Because you're simply seeing what's around you. You got your glasses, and what I'm trying to say is you see where you look at, right? You're seeing stuff that are in front of you, and you're not seeing the big picture. That's for sure. That's the case we all are in. So we need to be careful and in the know that we got that perceptional issue about about the social environment that we are in, especially the online social environment and the presence that we have. So all these questions, and yet at the end of the day, they all come to this. And let me dismiss this one. This is my productivity suite. So at the end of the day, these questions they go to the level where we're gonna pick a layer. And by layer, I mean, let's step back for a moment and think about, the usual programming languages, right? That we all somehow we are aware of it, or we know, or we use. So when you pick a programming language, of course, there are a lot of research out there that says, hey, this is the most popular programming language, this is the most picked programming language, and so on and so forth. But you don't just pick a language because it's popular. First of all, the purpose is important. What are you going to do with that language, right? I have never seen someone, at least I personally didn't see anyone, building an e-commerce website with C, right? Where you're going to build an e-commerce website today, I mean, there's always the question, do you really need to build it? Can't you just purchase one? But that's another topic. But let's say you want to build an e-commerce website. What languages do you prefer? Most probably you're not going to go and pick C and start from there. You will pick some kind of a higher level language, right? If you're going to build a real-time system, maybe the best option might be C or something else, but it might not be really C#, for example. So My point is, we know that there are high-level programming languages and low-level programming languages, right? And we know why they do exist. The same concept exists in the AI space as well. Thankfully, it does, because if it didn't, then we would all, be in that situation where if we want to build an e-commerce website, we would have to go to C, which would be painful. And this is a known problem, right? At the beginning of every technology, things start from the lower level and keep going to the higher levels to make it, more approachable, and so that developers can build stuff and add on top of it and bring the technology to the end user, closer to the end user. So 2 or 3 years ago, to be honest, it might be even 4 years ago, I will be talking about 3 different vendors here. Google, AWS, and Microsoft will be the 3. My demos will be mostly about Microsoft because that's what I know about. But at the end of the day, I did hear stories like, I know one. I'm not going to call out the vendors, but I know for sure that all these 3 vendors had such stories. And here's how it happens. So this big vendor, goes to a company, right? And they want to do an AI. They want to sell, an AI tool or service or whatever. And then when they do the presentation, the company comes back and says, "Hey, we don't have any data scientists in our team. We don't even have data engineers, and we don't have a team essentially who understands all that, underlying math and all that stuff, right? So there is no way for us to use this thing, and we really, somehow need it. We would love to use your tool, but we don't have the expertise." This is pretty much the beginning of, getting from C to C#, right, or C to Java. So you figure out that the tool that you have at hand is too complex and low level for the people who are going to use it in this particular case. So, and within the context of this story, what happens is that the company comes forward and says, "Hey, sure, we're gonna build you. Give us the requirements. We will build you whatever you need. We will use the tools and the services that we are selling, but we will use them for you. We will customize it. We will build on top of it and bring it to you as a solution that you can use." So at the end of the day, you might argue that there isn't a really good market fit in this case, right? The product that you're trying to sell is too low level for the consumer who wants to use it, and there isn't a real fit between it. And it is when you only have low-level, products or services or tools, right? And this problem has to be solved, right? Because at the end of the day, you want to have everyone use AI, and by that I don't mean the real consumer. I mean, startups, companies who are building software as a service products, companies who are building desktop apps, mobile apps. All these companies, they don't have the time or the investment to start a full-blown data science team and build their own thing. Very rarely they can do that. Very large organizations can do that. And if you want to democratize the technology and increase the user base, you definitely have to bring that lower level technology, build on top of it, and bring it a little bit to the higher levels so that people can use it. And that is what's happening during the last couple of years. Both Google, AWS, and Microsoft, and other companies that I didn't even include in this slide, like IBM, and maybe I'm missing something else. I don't know. But all these companies, they're bringing technology up on the stack so that companies who do not really have the power to invest can still use AI. So that's pretty much the topic of this presentation, and that is why it's called serverless AI, because that means there are AI services that come in a serverless fashion, which means you don't have to worry about the underlying infrastructure, not just the server layer, as whatever framework and tools and stuff that has to run on these servers. You don't need to worry about those. You will get essentially a software as a service solution, and you will start using it. You don't have to worry about the scalability and all that stuff. Essentially, you might even argue that you might not even know anything about AI to be able to use these services, except maybe a couple of those. So let's go into this. So I got a couple of services from Google here. And to be fair, Google didn't really, I mean, from my perspective, they didn't really do a very good job in marketing the services that I have. And the reason is, it looks like, I mean, in this slide deck, for example, it looks like they have only 4 products. But the other vendors like AWS and Microsoft, they did actually, partition all these tools and provided a better naming for their products. Or, this is open to discussion, obviously. But I know this looks like 4 products right now, but there is more in it. For example, object recognition is a separate product at AWS or Microsoft, but object recognition is part of the Vision AI product at Google. So out of the Vision AI product, essentially, you can actually separate that into multiple products and list them out separately. Unfortunately, or I don't know, from their perspective, maybe that's what they prefer, but they didn't go that route. So I just want to be fair that it's going to look, the list in this slide deck will look really short compared to AWS, for example, but that doesn't mean necessarily that Google has a smaller set of products. It's just because they decided to group multiple AI capabilities into a single product. And this is kind of a list from AWS that I grabbed, and this isn't the full list of AI services that they have. I kind of aggregated the list, the products that are serverless. This list might be at kind of 3 months old. So just so you know, if something came up during the last 3 months, it might be missing here. But this is pretty much what it is. So these services are serverless, which means, again, you don't have to set up any environment. Usually, you just simply go and use REST APIs, and that's it. You don't have to worry about scaling. They're going to do it for you. You will simply come in and pay per, most of the time it's just transaction or, the compute power that you use, but the billing is pretty much for all of these services. The billing is very granular, and that's what it has to be in order to call those services serverless, right? And this is a list from Microsoft, and I know this looks like a large list, and to be fair, it's not just that they did separate all of the functionalities into separate products. I know it might feel like it. I wanted to be fair to Google, and I wanted to be fair on Microsoft as well. It's not just that they separated all of these functionalities into different products. They do indeed have some interesting products in the list, and by interesting, I mean what I mean is Microsoft has always been a company who really wanted to target and started at times from very high-level products, and that's been a reason sometimes for the developer community to bash the approach of Microsoft, because when you have something high level, right, you cannot really go deep and change how things work, or optimize at a level that you might be able. So when you have a high-level product, there are a lot of assumptions that are taken granted when that high-level product is built, and sometimes these assumptions do not really align with what we need. And that's the nature of the thing, right? That's something we experience when in the cloud in general, right? If you're going platform as a service, there's no way you're gonna go in and change the configuration of the operating system, because the operating system is something by the nature of platform as a service, that's something you delegated to the service provider, right? That's pretty much what it is here as well. And that's a good thing, because for example, in this list, I'm definitely not going to do demos about every one of these services. But for example, the Q&A maker that you can see on the top of the list on the left, Q&A maker is a very interesting product. What you simply do is that if you have frequently asked questions FAQ on your website, you give the URL of your website. It does data crawling. You simply give the URL and click next. That's it, and it does data crawling. It does data cleaning, and it has language processing on top of it, and it has a chatbot on top of it, and it gives you a chatbot UI that you can embed on your website with a simple iframe. So think about it. I mean, let's go a step back, right? Let's start from the scratch. You are giving a URL on your website with questions and answers, right? And the service is giving you an iframe with a chatbot in it where people can ask questions and to get the answers. And there is a lot of, technology to enable this, and every piece of technology on the path can actually be and is actually a huge, expertise area, right? When we say language processing, and if you go into that, you can spend years, learning and customizing and building these things. But if we're talking about a high-level service, the idea is that it really needs to be a high level, right? The good thing is, especially with the Q&A maker, you can actually download a C# project, for example. If you want to customize the Q&A maker, it gives you the code that is being used by the chatbot, and you can, hijack the process, include additional functionalities, which is a little bit against the high-level concept of the service, but they are kind of trying to provide at least some flexibility, even though the service is really high level. So my point is, in the context of this Q&A maker, it's a very specific solution for a specific problem in the context of an AI service, right? And the other vendors, as far as I know, they don't have this specificity in their services, at least for now. They might build and come up with new, services, but the richness of this slide tag, again, it's not just because it's a very granular set of products. It's because Microsoft is really bringing up high-level services, and that's, from what I understand, that's one of their goals. Let's stop there here and continue with what we have, because it looks like I'm talking too much, right? Do we have any questions so far? It looks like not. Okay, cool. Yeah, I mean, let me know if you have any questions. Feel free to send them on the chat. Don't wait until the end, because if you have a question that's related to what I'm going through, I might be able to answer that on the fly instead of postponing it till to the end. So the first set of services that we can talk about is face recognition. We got face detection, face verification, and by verification, we don't necessarily mean authenticating the user, because even though biometric data is being used a lot for authentication, it's arguable that it's the best approach, because when we're talking about authentication, identification is something different, authentication is something different, right? So when you're authenticating people into a system, the authentication method should have something that it should have a key or something, an identifier that can be changed by the user. Let me give you an example. So if you're logging into a system with your fingerprint, right? If your fingerprint is stolen, there's no way for you to change your fingerprint. But if you're logging into a system with a password, then that's cool, because you can change your password. So face login, fingerprint login, these are all, arguably not very strong authentication methods. They should be used as an identification to identify who the person is. But to authenticate the person, we better use something else. That's what I would say. I mean, in this case, the services that we're talking are not even, considering the depth data of the image. So they're simply doing, image analysis. And the purpose is, to figure out, with some scoring, what are the people in a particular photo, for example. So you can teach the system, if you have someone, let's say, Brown. If you have someone called Brown and you got 10 of those photos of Brown, then you can actually define, give the 10 photos and say, hey, this is Brown. And then if you got a bunch of other photos, you can give to the AI and say, do you see Brown in any of these photos? That goes to the face grouping concept as well. You can give a bunch of photos to the system. It doesn't matter if the AI recognizes the people's identity. It can assign unique identifiers, random unique identifiers to every face. You can have hundreds of pictures in the system, and it will tell you, hey, here is the 55 unique people I found out of the 100 pictures, and out of this 55 people, here are the photos. Each one of them are in the photo. So it can give you the list as well. So let's do a small demo about this, right? Let's do a small demo. I got a Visual Studio solution here. See, what I did is, instead of creating a client application, I actually created a server-side app, which is going to talk to Azure's cognitive services. Let me run this and see the functionality first, and then we will go into the code and see how much effort I put to enable this functionality, because that's what's important, right? If you're talking about serverless AI and high-level services, that's what's important. So in this case, those are all local services that I have. These are all the demos that I'm going to do in the session today. And this is the endpoint that I'm going to hit, right? And as you see, this is a local endpoint right now. Okay. So let me get a browser window from here. Okay. So when we go into this URL, what we are gonna do is let me check the parameter, because it looks like my history didn't remember that. Give me a second. Okay. We will look into the code. Don't be worried for now. Okay, image URL. Good. So let's use a photo of mine. I will search for one of my photos from the internet, and I will, which one should we pick? Maybe this. Yeah, this might be good. Or this. Yeah, that's better. Okay, this is a good one. So what we are going to do is to go to the local API endpoint. This is the parameter that we will use, and we will give the image URL from this website. I will steal it, copy image link. That should do it. Here we go. So I am given a JPEG address in this parameter to my local API. Let's look at the original photo first off. Okay, this is me, and then let's see what we're going to end up here. I'm running the local API. There we go. So that's what this API is doing. It's doing censorship, right? This was the original photo, and this is the new one. So how much effort did I invest in building this functionality? That's the question. This functionality right now is totally scalable, right? We can have millions of requests coming into this API. There will be no problems at all. Obviously, I'm going to need to pay for it. But I'm not going to have any scalability issues or anything like that. And how much time did I invest to build this? Let's see. So in this case, this is the local code that I'm running. Let's open it up. And here we go. So what I'm doing is we are using a couple of REST APIs from Cognitive Services, and there's a C# SDK that wraps the APIs. And in this case, because I'm writing C#, I will be using their SDK. And there's a lot of SDKs for a lot of different languages, by the way. I was surprised. Someone recently in a presentation where I was the presenter, someone asked, hey, is there a Go SDK? And I said, I don't know. Just check it out and let me know. And the guy actually checked it out and told me that there is a Go SDK. So I know this might sound a little bit surprising if you're not in the loop in the Microsoft's last 5 years. Then you might be surprised that Microsoft is building SDKs for various languages out there. But that is the case. So there's a big chance you're going to find an SDK for the programming language that you're using. And even if there isn't, it's just a REST APIs, to be honest. If you're able to send HTTP calls, then you should be able to use this. So in this case, I'm using the Face client. I'm passing a subscription key. That's something I got from the Azure portal. That's a service. The AI service is something from Microsoft, and it's wrapped in an Azure subscription. And I get a service key from the portal. This is what that is. And then I have to give an endpoint for the for the service that I will be using, and the key, the endpoint, and that's pretty much the setup. And finally, there's this method that I'm calling, detect with URL async. I'm given an image URL parameter, and I'm passing two, booleans, which are, should I return the face ID, because we are doing face detection. Returning face ID means a face ID uniquely identifies a unique person, which means, if I get, for example, the face ID is obviously not a simple integer, but let's assume that was a simple integer. If this API returns, 2 for the face ID in this image, I expect the API to return the same face ID if I give another image with me in it. But if there is someone else, then that other person will have another unique identifier. So face ID uniquely identifies a face, and it helps understanding if the same face is showing up on another image. We can, obviously, if this Boolean is false, we're not going to get any face ID out of the API. If you don't need it, you don't use it. The second Boolean is about face landmarks. Face landmarks are the eyes and the nose and all that stuff. In this case, we really need it because, as you've seen in the example, I was actually replacing, blurring the eyes. So for me, it's important to figure out where the eyes are. I don't simply want face, detection. I want eye detection as well, and that's why I gotta pass through as the face landmarks parameters. And finally, I get a list of faces. And in this case, there's only a single face, but there might be multiple faces. So, and this is pretty much it. I mean, from an AI perspective, and I know this isn't AI, to be honest. We're just using an SDK and doing REST API calls, and that's the whole point. Without really knowing anything about AI, I am able to implement a piece of AI, at least an AI functionality into my app. So you might be wondering, hey, what are you hiding in those, prep and output call blocks, right? Let me show you that. The prep section is actually getting, the query string parameter into a variable, and obviously I got some config stuff that has to be stored somewhere, like the subscription key, the endpoint. They're all coming from the config repository in my app. And that's what this code is about. So essentially nothing that, just a plumbing to, get things running. And finally, in the output, obviously I have to do the blurring, right? So let's look at the output. And when you look at this code, keep in mind that this is just, for the sake of a demo, this is definitely not the way to do things. I mean, don't create an HTTP client every time when you're building an Azure function, for sure. So don't take this code as an example of doing things the right way. This is just proof of concept. So what I'm doing here is, the important part here is this one. See, so I am getting the first face out of the face list. I mean, in this case, I don't care if there are multiple faces or anything, because this is just a demo. I'm simply getting the first face out of the face list. And from the face list, I'm going through landmarks and see I left outer x minus I size, which I calculated here, right? And I write outer, blah, blah, blah. So essentially what I'm doing is I'm creating a rectangle that will cover the area of the eyes, and then blurring it. And again, even the blurring, even this code isn't fully, functional. In this case, from the perspective of the person, the left eye has to be, from the perspective of X coordinate, the left eye has to be lower than the right eye. I mean, that's a long story, but not every image will work with this code. There are cases where this code will fail. So again, this is just for the demo, but with some little improvements in both code quality and functional implementation, this can be a nice one. So yeah, the thing is, again, let me close those things, and because these are again plumbing, but this is as much as I had to do to implement face detection and eye detection. And again, this has nothing to do with AI, right? This is just REST APIs. Okay, cool. Do we have any questions? I don't think so. Good. Let's go back to the presentation and see what else we have. So we got a computer vision. Again, this is a set of APIs. You can give an image and do object detection, get an idea of what's in the image and where the object is. You can do OCR. You can, do celebrity recognition. There's a lot of, if large database of, in this case, 200,000, but it might be more than that because, this number is maybe 1 year old. So there might be more than that right now. So you can recognize celebrities. You can even recognize, businesses if they, if there's a logo of the business in the image. So essentially, you give an image and try to get as much metadata out of the image as possible. So one of the APIs that I really like in this set of, services from computer vision is the smart cropping. So let me tell you the story about this. If you're using Twitter, if you're not, I suggest you do it. If you tweet a photo, for example, a photo with someone, looking to, I actually have an example of it. Let me show it to you. Instead of, explaining the whole thing, let me open this this photo and show you what I mean. So this is a photo that if I tweet, right, might be, the man on the right-hand side might be cropped, right? Because the photo's ratio, the height and width ratio, doesn't really go along with the ratio that Twitter needs in its timeline. So someone has to do some cropping. And when you do automated cropping to a different ratio, you might actually cut the man out, or maybe half of the man out. And that wouldn't look nice. So ideally, what you can do is, if you could detect the point of interest in this photo and then crop accordingly, that would be a smart cropping. And that's exactly what the service is doing. And imagine, this is, you can tweet right now and see this in action. So think about this. You wanna do this, and do you really want to spin up a data science team? Do you really want to do that? No way. And well, what's your option then? And large companies, large enterprises can do this if they have a data science team, they can do this pretty easily, maybe. And how are startups going to compete with those large enterprises if they don't have the power to invest and build their data science teams and make this possible? And that's where the high-level services come in, right? These high-level services help small companies who can invest, add AI functionality, add value into their products. Obviously, you might argue that, hey, what is the value of this and smart cropping for Twitter? If you know a product manager, talk to them. I'm sure they will explain to you. But user experience, I would say, step one. That's very important, obviously. And you really don't. Think about it. If you got two, companies providing functionality, let's say there's another Twitter, and we got the original Twitter. If the original Twitter is doing smart cropping and the other Twitter is not doing smart cropping, that's going to be a decision factor for consumers. And you got to compete. And that's why these high-level services are out there. And you might even argue that I did hear this from, I did this presentation a couple of times, more than a couple, to be honest. But, one of the arguments is that, is this really what we're calling AI? Is this, when we were talking about AI, it was, I had higher hopes. Like I had some, my imagination goes further than smart cropping. And I definitely agree with you. Most of the time when people talk about AI, what they're talking about, what they have in their mind is the artificial general intelligence, right? An AI that is conscious and that can respond to things. That's what we are used to from science fiction movies and books. So the sad news is that there is no consensus all over the academia that the general artificial intelligence is doable. So that's the sad news. That actually, that might not be a sad news. The real sad news would be if we knew we couldn't do it. Right now, we don't know if we're going to be able to do it or we're not going to be able to do it. So you might even consider it good news. My point is, when you are thinking about AI, remember this example, because this is a very good example of the use of AI to bring value to a product. Okay, and this is where those high-level AI services come in. So in this example, what I'm going to do is pass this URL as a parameter to one of the APIs that I already have in my environment here. Where is it? Here we go. I'm going to pull out this endpoint, smart thumbnail. I will show you the code just in a moment. So this is it. Smart thumbnail, image URL equals to, let's copy this one. Let me show you what I'm doing. Image URL for smart thumbnail, and this is the URL of the photo. Let's see what happens. There you go. So the image is cropped, but the man is still in the picture, right? You can see how the cropping is happened. And I cropped a 500 to 500 pixels square out of this image by keeping the point of interest in the picture. And how much effort did it took? Let me show that to you. This is it. This is all I had to do. Create a computer vision client, give the subscription key, the endpoint, and then we got a method that says general thumbnail async. I give the width and height. It needs to be smart, obviously, and then the image URL. So keep in mind, I don't even download the image and give it. I mean, I can do it. I can download the image and give it to the API as a stream, but I can be as lazy as not even passing the image to the hosted service. I simply give the URL and go fetch it yourself. So that's really the level of help you can get from these serverless AI services. In this case, the preparation is the same, just config and parameter stuff, and the output is simply writing the output we get. We get a stream out of the thumbnail method, so I have to write this stream into the response output. That's what I'm doing down there. So again, this is all that is about AI. And this is not AI, right? Isn't this fun? Because I really like this. I mean, right now, I'm not sure how you guys are reacting, obviously. I don't see you. But when I do this presentation, face-to-face, it's really fun to see, like, hey, I can do all this stuff without really, learning a thing about AI. And, that's a good place to be. I'm not saying, you shouldn't learn AI, but being able to do these, fundamental AI functionalities, features, implementations, without really having to go and learn stuff for weeks, that's a good thing. So video indexer is the next one. I'm not going to be able to do a demo about this because the demo takes really a long time because you're processing video files. But let me talk through a couple of things that you can enable. And at the end of the slide, I'm going to share you a website where you can do some, a playground website where you can play with these services. But what we can do here is we can give a video file. The video file will be analyzed. If there are celebrities in it, they will be recognized. The talks the system will be able to go through it and differentiate who is talking when during the video based on the sound and the tone of the voices. We can transcribe what they're saying. Out of the transcription, we can do a lot of other things like sentiment analysis, keyword detection. We can understand in the context of a 60 minutes video, we can detect actually how many people are talking about an Apple and what's their feeling at that particular point in time. So we can say, yeah, this is a 60-minute video. During the between 2 and 4 minutes, people are talking about Apple, and this is, I mean, they had a feeling of 60 or 70% positivity during that time frame. We can say, like, I got a 60 minutes video. During the 6 and 7 minutes, person A was talking and person B was not. During the full video, there were 3 unique individuals. We were able to recognize 2 of them through the celebrity recognition, but the other one, we just have a unique identifier and we don't know who that is, but we can still, detect when they talk during the 60-minute video, right? I mean, you can do brand recognition, OCR, text analytics, all that stuff on a video, and that means you can get a lot of metadata from a single video file. What do you do with that metadata is totally up to you, right? You can come up with a new startup idea or whatever you want, but you don't have to build the infrastructure to be able to analyze a video and extract all this metadata. You can simply go out and use one of these services. And again, I'm going through services that Microsoft has in Azure, but 80% of the time, all these cloud providers, they do have matching products, and it's always a good idea to look into all of the providers, because in some cases you might see that, hey, it looks like AWS is better than Microsoft in this particular service, but Microsoft is better than AWS in this other one. So it's always smart to compare these services, and especially if in the context of geography and language and culture, it's much more important to make sure you compare different vendors, because they might be stronger in some geographies and a little bit weaker in some. For example, if you're doing celebrity recognition, if you're in the US, Azure might be great. If you are, in, I don't know, Egypt, maybe you're going to go with Google. So you definitely should go and do some analysis and compare all these vendors in the context of their services quality, and if that's important, in the context of the geography. You might even do things like, yeah, I'm going to do celebrity recognition in my product, and my product is global, and I will use Azure for this particular geography and AWS for this other geography, because I want to get the best out of all, right? And that is important. That is something you should definitely keep in mind. So the custom vision is an interesting one, because custom vision, look at this slide deck. It's the first time we are using the word train, right? Evaluation and learning. It's the first time we're talking about these 3, concepts. And my point is, so far we didn't say anything about AI. I mean, we used AI in our sentences, but at the end of the day, we simply used REST APIs. But right now, we're talking about training data set, evaluation of the model, and doing active learning. So it looks like we're a little bit getting into the thing, and that's because it's custom vision, which means you're able to customize a little bit further than what the very high level services can provide. So what do we have really? So in this case, we have, let's say we're not able to use any of the services because they don't essentially have what we need, right? They can do apple recognition, they can do banana recognition, but there is this tropical fruit in my region that, AWS doesn't know about. They don't have enough data. They don't recognize that particular fruit or plant, but I do have thousands of photos of that plant. So what if I want to, train my own model? What I'm going to do? What can I do, right? And obviously, this is not rocket science, and there's a lot of, libraries, Python libraries, and all that stuff out there. You can, there are a lot of, TensorFlow is the one that I was trying to remember. Anyways, so this is doable, but again, think about it from the concept of serverless, right? Think about from the concept of the high-level services. How can we make this thing really easy? And that is what the custom vision service is about. When we launched the custom vision service, this is a screenshot that I wanted to show you because this isn't the exact demo that I'm going to do. I'm going to go with a simpler one just for the sake of this demo and the time we have. But simply you can upload images and select if you want to do multiple object recognition. You can use your mouse and select the object. Tell AI what that object is and create a data set, and then train your model based on that, and then start using it. You can even export your model if you want to. But I mean, you don't have to use Azure all the way. You can do the training in Azure, and you can extract your model, and you can extract the TensorFlow model and Onyx model, and go ahead and use wherever you want. So let's see what we have here. So in this case, what I'm going to do is let's shut this down. We don't need it anymore. And let me bring this browser UI. So here what I have is a custom vision test service that I provisioned from the Azure portal. Let me go into there. Okay, so when you open this for the first time, it starts with the quick start, which is good, right? And there's this link on the second step that says custom vision portal. So in this case, I didn't really write a simple app because I don't need to. There's already a simple website that we can use to, play with the APIs. Let me open it up. The website is called Custom Vision AI. You can, visit that directly as well if you want. But you're going to need to get a cognitive services account from Azure first. That might be better. I will click sign in to use single sign-on, and there we go. Oh, this is a first. Okay. I have been here before multiple times, but the first time I got the agreement. So let me delete the project. So we're going to create a new project. I will give this project a name, say, my deduction, whatever. And I pick the cognitive service that I'm going to use from Azure. In this case, I'm going to use custom vision test that I created. F0 means it's on the free tier. I'm not going to be paying for this. I just want to do testing. We will do classification, not object detection, because it's easier, and I don't have a lot of data to go through the other examples here. Single tag per image sounds good. That's what I want to do. Multiple tag per image is the one that I showed you in the deck with the screenshot. And here is a couple of domains that I can pick. If you pick a domain, a specific domain, you will have a pre-trained model that you can add on top of. If you select the compact models, you can export your model and run it on a mobile phone or somewhere if you want to. In this case, I will simply go with general. Okay. So everything that you see from now on, every operation that I do on this website are actually, REST APIs. And there is documentation about it. I could have built an app that does all that I'm going to do right now. The reason I didn't build it is because first, I'm lazy, and second, there is this website. There is no need to build it. But my point is, if you want to do it, if you want to automate these operations, or if you are going to make these, functionalities part of your app, that is definitely doable. So here's what I have. So I got a bunch of car photos. There we go. Okay, I will give these car photos, and it looks like these are in OneDrive. So let's download these for a moment. I hope it happens fast. Do we have any questions, by the way? No? Good. In that case, it feels like I'm doing a very good job. If there are no questions at all, it looks like we got the cars downloaded. Okay, cool. So I will click this button that says add images, and I will start adding some images. In this case, those are cars. And when I upload these images, I'm going to say, hey, these are cars or car, right? Upload 30 images. So let me show you the photos. What do we have in here? Oops, wrong monitor. So we got an old car. I got all these photos from Google, by the way. Just, it's some nice cars, new, old, low resolution, high resolution, right? This photo is definitely edited. Wow, a rusty car. A car with no background, right? Yeah, it looks like all of the cars, and those are pretty small images, though. Yeah, it looks like all of the cars, all of the photos are showing the front side. Wow, that's a nice one. All of the cars are showing the front side of the car, so there's no picture from the back of the car, right? So upload completed. So let's add another set of images, and in this step, we will go and add 5 photos of buses. So let me add that in write bus. Right? And let's see what photos we do have here. So a Lego bus, a regular bus, and another regular bus, and another bus, and another one. Again, this one is from back. Good. So just 5 photos, which is a little bit hard, to be honest. Not a lot of data, right? To teach AI what a bus is, but let's give it a try. So the next step is we did upload all of the data. We flagged the data set, so we are ready to do some training. So I will click train, and training has started. Obviously, I did use all of the data that I have, and I don't have a lot of data. But usually, what you do is, you pick a subset of your data, you do training, and with the other subset, you do some testing and comparison, and understand, what your success rate is. Okay. Oh, unbalanced data detected. Yeah, I bet. Okay, great. So let's do a test. Our model is ready. So there's a test screen here where I can give a URL and say, hey, what's your prediction? What do you think this image is? So let's find some. What is that? Weird sound when accelerating. That's weird. Okay, weird car. Hey, yeah, this one, I bet. I mean, there's a big chance this is gonna be, interpreted as a bus. Let's try it. Let's give it a try. Image link, paste it, and go. Yeah, 99% bus. I was right. So we need more data. If we want to improve this percentage, we need more data. Let's go with something else. Something that looks like a little bit more of a car, right? Do we have a car from the back? Car from the back. Okay. So, for example, this one. So this is a car from the back. We don't have any photo like this in our training data. So let's see what AI will say. Oh, the link didn't work. The image link isn't. I don't think it's proper. Okay, let's try something else. This is another. No, I want the direct link of the image, and I don't have the time to visit the website and capture that. Okay, let's try this. Oh, 100% car. So that's good. That's good prediction, right? Because in our training set, there is no, photo of a car from, taken from the back. So that's good. What about buses? Weird bus. Let's search for it. Oh yeah. Oh, this is a. I'm guessing this is obviously edited, but let's try it. Copy image link. Go. Yeah, this is 100% bus. Great. So, what if I give a photo of a, I don't know, bicycle? What are you gonna do? Let's pick a better, cleaner photo. Okay, this one. Hey, that's interesting, right? This one is interesting. So here's what we have to understand about what's happening. So the AI doesn't really know what a car is. We might think that, hey, it didn't we teach it what a car is? No, we actually didn't. What we did is we did give a group of photos and another group of photos, and we labeled those with different names, identifiers. A car doesn't mean anything, right? I could have flagged those 1 and 2. And then we asked AI to look into these groups, right, and figure out the commonalities between them from the perspective of the most different commonalities, if that makes sense, right? So find the commonalities, and out of these, find the ones that are as far away from each other as possible, and once you got that, now I got you a new photo, and tell me how close it is to one of these sites. So you can think of this like a goat, right? We got a panel in the middle, right? And there's bus or car. And we're asking the AI, hey, what is this about? Is this a bus or car? Is actually the question we're asking, right? How much of a bus is this? How much of a car is this? That's the question we are asking the AI in this particular case, because we got classification and we got single tags. So the AI has to respond, right? It can't say, hey, this is 0% car, 0% bus. There's no way the AI respond that way, because the question we are asking, hey, can you give me the probability that this is a bus or this is a car? That's the real question. So the worst case that the AI can decide, the worst case, the answer will be this is a 50% bus and a 50% car. So that's the worst case. So what we do when we implement these, these functionalities into our app, we decide, a level of, probability that makes sense for our implementation. For example, if something isn't predicted to be, a 90% car, that might not be acceptable for my implementation. And I gotta decide on it. And the way to decide on it is, run experiments and figure out what's the best, level based on the data set that you have and the model that you build. And then, you decide the level and you define it as the least acceptable probability for your application to be able to proceed with the prediction. Cool. Yeah. And in this case, again, you can, all of the everything that we did on this website, there are APIs to do these things. So you can build a mobile app that can upload images, start training, and the prediction, the quick test, there's an API for that as well. So everything can be done from whatever client that you can imagine. At the end of the day, this website is actually using the APIs of the custom vision cognitive service here. You can get the keys from here, connect to this API, and start using it any way you want. Cool. Okay, let's go. It looks like we're 3 minutes over. Yeah, we got speech and language. I'm not gonna do demos about those. I do have demos, but I will not go through them because I'm not sure if the sound of my computer will go through, and these things might not work at times. So, and we are getting out of time anyways. But the examples are, are stored in my GitHub repository. If you go to github.com and you search for my name and last name, you can definitely find those out. And if you can, feel free to ping me on Twitter if you want to. So speech, simple things like speech to text, text to speech. Speaker recognition is something we kind of mentioned during the video part, right? Being able to analyze speakers in video files. Speech translation, again, the language, the culture is very important here. So go ahead, look at the different vendors and try to figure out which one is the best for your region. The other one is in the language. So you can give a sentence and get a sentiment percentage out of it, how positive the feeling is, or what type of feeling that can be extracted from a particular text. You can extract the keywords, you can extract celebrity names, you can extract, business names out of text. You can do, again, text translation. Content moderator is an interesting one because there is some built-in moderation that can happen in the content moderator API, like full words and all that stuff that can be removed. But then there's a tool set as part of the service. There's a tool set that you can use to moderate content manually by real people, real agents. So you can combine AI and real agents. So the AI steps up first and moderates the content, but if the AIs, if the probability of some of the detection algorithms are lower than what we want, then we can fall back to a real human agent. And if you want to do that, we got to build some kind of a flow and give some tools to the agents, and all of that, the whole suite of tools are actually part of the content moderator service. So if that's something you want to look into, this might be a good one to go with. Okay, so these are a couple of links that I wanted to share. The Video Indexer online playground, that's a website you can go and start playing with. Cognitive services documentation, this is the REST API endpoint. If you're looking for an SDK, go Google for it. I'm sure you will find it, but I just want to at least put the REST API documentation here so that everyone can use it. And finally, the custom vision part, the demo that we did, I know it looks nice. And if you are interested in learning more about custom vision, here's a video from 2019 from a Microsoft conference called Vision. Ignite. Vision is the name of the service. Ignite 2019 is the name of the conference, and there is if I'm not mistaken, there's a 2 to 3 hours long video there where they're going into the details of the custom vision product. So if you're interested, make sure you grab that one as well. It looks like we got a question there. Okay, I'm gonna let me see. Oops. Yeah. I'm not sure if I can bring that onto the screen right now, but still, let me. Oh, am I getting some help from the backstage?
Hello again.
Hey. So there is a single question. Let me read it out loud. So first off, thanks for the information. Okay, there you go. How can we convert to images points to numerical values? How can we convert to images points to numerical values? Images points. I'm trying to figure out in what context you asked that question. What does images points mean? Are you referring to the coordinates and the face landmarks, for example? Because they do actually come in numerical values. Maybe I should continue reading your question. For instance, what if you want to convert to slope of the windshield of car? Okay, yeah. That's not something you are going to be able to do with these high-level services because, that's a good one. Even if you can do windshield detection, actually you can do it. But that's a good question. I don't think you can do it with these high-level services. You want to calculate the slope of the windshield. I don't think you can do it. Well, the best you can do is detect the windshield and detect where the windshield is. But once you do that, maybe you can, I don't know, you can crop the image and then do another round of processing, which kind of, I'm not sure why would you do that. I mean, you better go all in and build your own thing. So long story short, I'm kind of pushing myself hard right now, but I don't think you can do it unless I'm missing something, and the chances that I am missing something is like 3%. Okay. Cool.
I love your confidence right there.
What was that?
I love your confidence.
Yeah, I mean, to be honest, I didn't want to say I'm 100% confident, which is the way I feel. But there's a chance definitely that there's something I don't know about and I'm missing. So, and 3, 5, 10% doesn't make any difference. So, oops, sorry. So this is. Oh, we're not seeing my presentation, right? Can we bring it up, the presentation as well? Cool, because that's the link where you can grab this particular deck. And if you want to grab the codes, it looks like I didn't put a link specifically for the codes that I used, but if you go to GitHub, you can definitely find it. And again, if you don't, feel free to ping me on Twitter. That's all I have.
All right, thanks for the great talk. Although, it was pretty long, but it was really interesting throughout the whole time. I really liked the demos and everything you gave. And I hope we can have you here again.
Sure, why not? Yeah, I really liked it.
Thanks a lot for taking time on your weekend.
Yeah, thanks to you for being my host.
Always a pleasure. So hope you have a great remaining weekend.
Oh, there's another question. It's not a complete sentence though. Yeah, you know what? Yeah, was ping me on Twitter. Send me your question, and let's get you the answers that you need. Okay. Thanks, everyone.
All right. Thank you so much. Have a great day. Bye-bye.
Thanks, Sarah. You too. Bye.
Thank you, everyone, for tuning in. Stay tuned next week for another webinar. Hope you all have a great weekend. See you later. Bye-bye.